Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be adding integers using models. The models we'll be using today are counters and number lines. Before we do, let's just review what an integer is. So an integer is the set of all whole numbers and their opposites. So we know the whole numbers start at 0 and then continue by counting up 0, 1, 2, 3. Well, integers just adds in the opposite of all those. So like -2, -1, 0, 1, 2, ... So all the whole numbers and their opposites are integers. Now we can model integers using counters, or some people call them chips, or number lines. Let's talk about counters first. So when we're using counters, or some people call these chips, you're going to have a positive counter and a negative counter. When you have one positive and one negative counter, they are called a zero pair, because when you combine them, you get 0. All right. So in example 1, it says write an equation to represent the value of the model. So in our top row, we have 3 negative counters. So that would be -3 plus. On the bottom row, we have 4 positive counters. Now, to get the value, what we're going to do is we're going to zero out any 0 pairs we have. So we have a negative and a positive. This would zero out, this would zero out, and this would zero out. And whatever's left over is our answer. And we have one positive counter left over, so I'm going to put +1. So when we take -3 and add 4, we get +1. All right, in our second problem, we have 1, 2, 3, 4, 5 negative counters. So that would be -5. And we're adding that to +3 counters. Now, to get the value of this equation, we're going to zero out anything we can zero out. So 0, 0, 0. What's left over will be your answer. So -5 plus 3 would equal -2. All right, in problem C, we have 3 negative counters, so that would be -3. And then we have 1, 2, 3, 4, 5, 6 positive counters. Now, it's a little harder to zero these out because they didn't line them up, but that's okay. Take a negative with a positive, zero that out. Here we'll take another negative with another positive and zero that out. Then take this negative with this positive and zero that out. Whatever's left over is your final answer. So -3 plus 6 is equal to +2. Now, notice that our first answer and our last answer were both positives. But our second answer, the one in the middle, B, had a negative answer. I want you to look at the counters and think about why were problem A and C, why did they have a positive answer? All right, hopefully you said they had a positive answer because there were more positive counters. In problem B, when we had more negative counters, our answer was negative. All right, example 2. Use counters to model each equation and then find the solution. So we have -2 plus 4. So what we want to do is draw this out. We have 2 negative counters. So I'm going to draw 2 negative counters. And then we have 1, 2, 3, 4 positive counters. All right. So now we've drawn the model. Now we're going to zero anything out we can zero out. So this 0 pair would zero out, and this pair would zero out. Whatever's left over is your answer, and we have 2 positive. So -2 plus 4 equals positive 2. All right, try problem B on your own. Pause the video. When you're finished, come back and check your answer. All right, welcome back. I drew 3 positive counters in my top row. In my bottom row, I drew 4 negative counters. So I'm noticing that I have more negative counters. So I'm thinking my answer is going to be negative. So let's zero this out, zero this out, zero this out. We have 1 negative left. So 3 plus negative 4 is negative 1. All right, pause the video and try problem C on your own. All right, welcome back. To model this, I did 3 negatives, and on the bottom row, I did 2 negatives. And what I'm noticing is that nothing will zero out on this problem. So 1, 2, 3, 4, 5. Negative 3 plus negative 2 is negative 5. All right, example 3. Tell whether the solution to each of the following would be positive or negative. Do not solve. So in problem A, we have negative 7 plus 4. So what I want you to visualize is that you're going to have 7 negative counters on the top row and 4 positive counters on the bottom row. Well, because there are more negative counters, your answer will be negative. All right, now what I want you to do is try B, C, and D on your own. Pause the video and then press play to come back and check your answers. All right, welcome back. I said on problem B, the answer would be positive because there were only 2 negative counters, but there were 5 positive counters. On problem C, I have negative 20 counters on the bottom and negative 30 counters on the, negative 20 on the top row and negative 30 on the bottom row. So this answer would be negative. And then problem D, I have 23 negative counters on the top row and 87 positive counters on the bottom row. So this would be a positive answer. All right. Now, in the first page, we used counters to model integer addition. On the second page, we're going to use number lines. So when you have a problem that you're supposed to model on a number line, like negative 2 plus 6, the operation symbols are your directions. So this negative symbol right here, that's telling me to move to the left. And then the 2 tells me how far to move to the left. And then this plus sign right here, this tells me move to the right. And the 6 tells me how much units to use to the right. So if I look at this number line, we always start at 0. And they had you go 2 to the left, which landed you at negative 2. And then 6 to the right. 1, 2, 3, 4, 5, 6. So it landed at positive 4. So the answer here, negative 2 plus 6 would be positive 4. All right, in example 4, write the equation that is modeled by each number line model. So remember, we always start at 0. Now, the first arrow moved to the left, so I know that's going to be negative, and it moved to the left 4 places, so that's negative 4. Then we move to the right, so that's plus. How many did it move to the right? Well, 1, 2, 3, 4, 5, 6, 7. It moved 7 to the right, and it landed at positive 3. So negative 4 plus 7 is positive 3. Think about it. You have 4 negative counters and 7 positive counters. So 4 of them are going to cancel out and just leave you 3 positives. All right, in problem B, starting at 0, they move to the right 4. So that is positive 4 because they moved to the right. Then they move to the left 1, 2, 3, 4, 5, 6, 7, 8, 9. So they move to the left, so that is negative 9. And they landed at negative 5. All right, pause the video and try problem C on your own. When you're finished, come back and check your answer. All right, welcome back. So they started at 0 and moved left 3. So that's negative 3. Then they moved to the right 1, 2, 3. So that's positive 3. And they landed at 0. So negative 3 plus 3 is equal to 0. And think about it. That's like having 3 negative counters and 3 positive counters. Well, every one of those is going to zero out and leave you with nothing. All right. Problem 5. Use the number line to model and solve the addition problems below. So in problem A, we have negative 3 plus 8. So we always start at 0. And the direction, because it's negative 3, is left 3. So 1, 2, 3. Then our second number line starts at negative 3 and goes 8 to the right. So 1, 2, 3, 4, 5, 6, 7, 8. So it lands right here. And it landed at positive 5. So negative 3 plus 8 gives me positive 5. All right, problem B. We have positive 1 plus negative 3. So you always start at 0. Because the 1 is positive, I'll go to the right 1. Then the 3 is negative, so I'll go to the left 3. So 1, 2, 3. And that ends up at negative 2. So 1 plus negative 3 gives me negative 2. All right. Pause the video and try problem C and D on your own. All right, welcome back. On C, I started at 0 and I went 4 to the right. And then I went 4 to the left because the second 4 was negative. And that landed me at 0. 4 plus negative 4 gives me 0. All right, problem D. We have negative 1 plus negative 4. So starting at 0, I'm going to go left 1. Now, here, I'm going left 4. So I have to go 4 more to the left. 1, 2, 3, 4. So the answer is negative 5. Now, let's talk about this with counters. I had 1 negative on the top row and 4 negatives on the bottom row. And that gives me a total of 5 negatives. There were no 0 pairs. Nothing canceled out. All right, example 6. Solve each of the following by either model. Now, when they give me a choice, I always use counters because number lines take a long time to draw. So unless you have a laminated number line and a dry erase marker where you can erase every time, I think counters are probably the fastest way to solve problems like this. So in problem A, we have negative 5 plus negative 5. So our top row is going to be 5 negative counters. Then we're adding 5 more negative counters. So ask yourself, will anything zero out? No, because to have a 0 pair, we need 1 positive and 1 negative. So just count up all your counters, and we get negative 10. So negative 5 plus negative 5 gives me negative 10. All right, problem B, we have 2 plus negative 4. So I have 2 positive counters for my top row, and then I have 4 negatives. 1, 2, 3, 4. Now, before you write your answer, you want to zero out any 0 pairs. So I have a 0 pair, 0 pair. Whatever's left over is your answer. So 2 plus negative 4 leaves me with negative 2. All right, problem C. We have negative 1 plus 6. So I have 1 negative counter, and then 1, 2, 3, 4, 5, and 6. Zero out anything that will zero out. So what's left over is 1, 2, 3, 4, 5. So negative 1 plus 6 is positive 5. All right, pause the video and try problem D on your own. All right, welcome back. So I had 3 negatives on the top and 3 negatives on the bottom. Nothing zeroes out. So negative 3 plus negative 3 gives me -6. And that concludes today's lesson, adding integers using models.